Well, good evening, everyone, and welcome to our long-awaited, delayed Dome at Home. I'm your host, Scott Young, planetarium astronomer at the Manitoba Museum, and it is really good to be back after a rather crazy week. We thank you for all of you that sent your emails of support and things like that. For those of you that didn't hear, one of my family members is in the hospital and everything's okay, but that happened right around Thursday. And it was just impossible for me to keep my mind on putting a show together, let alone actually going on air. So we delayed things for a week, and hopefully that people will find their way to the show. But anyway, thank you all for your support and your patience. All right, tonight we have lots of cool things going on. We are going to be taking a look at the planet Mars as our sort of featured topic. We're also going to be looking at a few other things that might have happened in space news recently. There might have been one or two small things that we might find time to talk about. And we'll answer questions as usual, so feel free to drop your questions in the chat there. And great to see so many folks checking in. Do say hello in the chat, even if you're you don't feel like, asking questions or things like that. We love to know, where you're watching from or how many people are watching or things like that. Really, really helpful for us back in the Dome at Home central office, which is basically in my head. But still, it's very useful for us to have that kind of information for our bosses. Okay, let's see. We're broadcasting as usual from here in Winnipeg, Manitoba, Treaty 1 territory. And so all the things that we're going to talk about will be given in Central Time, but most of them can be just adjusted to your own time zone. I know we have folks watching us from the east and from the west and from south of here. And so most of the things that we will talk about, you just have to adjust for your own time zone. There are a few events that it's a bit more complicated than that, but in most cases, you just convert the time and you're pretty much good to go. All right, it does look like it's clear across southern Manitoba, at least mostly clear, and out into northwestern Ontario. Thanks, Jacqueline. Definitely looks like we'll get some nice skies tonight. And so after the show, I'm hoping to go outside and set up the telescope, and assuming that happens, I'll do some live streaming on my own Scott the Skywatcher page on Facebook. But that's later. First, let us begin with
Cool space stuff.
Now, it was really hard for me to sort of, we were off for a week, and there really wasn't a whole lot going on in the space exploration field for me to talk to. I really had to scrape to find some content. Obviously not. The biggest space news ever, really, is the launch of the Artemis mission to the moon. It got off the ground. They actually launched this rocket. Those of you that were with us for the launch, it was a late night, but it was kind of magical. I wasn't sure that it was going to go. They had some fueling issues as they had several times, but they got that resolved. They were only about half an hour, 45 minutes late. And the countdown goes, and then there's another hold, and then there's a countdown, and it continues on. We get to T-minus 10 minutes and holding, and I'm thinking, okay, well, something's going to happen now, and they're going to cancel. Because once you start the 10-minute countdown, you're pretty sure you're going to go, because a lot of the things start to happen very quickly and on automatic. And they went around the room, and everything was go. So the clock started counting down from 10 minutes. Got to 7, got to 5, got to 3 minutes. And at that point, I thought, this might actually happen. And it did. It was a beautiful launch, a night launch. The only downside, of course, is that really all you get to see is the fire part. As soon as it flies above the launch tower on this image here, the spotlights aren't lighting it up anymore, and all you see is the fire part. So you don't really see the rocket, but still, spectacular launch. The solid rocket boosters for the first 2 minutes, and then the rest of the engines for about 8 minutes, getting up into Earth orbit, and then deploying the Orion spacecraft, the solar panels folding out. These images that came out were actually really kind of intriguing at first. as you may know, I make models of spacecraft, and so I've looked at a whole bunch of pictures of the Orion spacecraft in processing and so on, and I've never seen these colors. And it took me a little while to realize that's the reflection of the Earth, the blue Earth, reflecting onto the metallic capsule that's giving it that really interesting sheen. And it never occurred to me, of course, that it wasn't going to look the same as it would in the vehicle assembly building with the big white spotlights on it. So pretty cool to discover that. It really is a beautiful spacecraft. And of course, right away, we see that NASA has really learned a number of things from watching both companies like SpaceX and also the Chinese space program. They put some selfie cams on this spacecraft. Each solar panel has a camera at the end, and sure, they're to look back at the spacecraft and make sure that they can see if there's any problems, but really, it's for taking cool pictures like this of the spacecraft and the moon. They're also sort of dark blue metallic, and so the light reflected off of them also adds to the sheen on the capsule there. There you can see one of the cameras just right at the end there. That's basically what they have there. And they can steer it around a little bit to look around at the spacecraft, but most of the time they would put the spacecraft sort of right at the edge of the view so that they could see something beyond, whether it was either the moon as we were approaching the moon, or whether it was the Earth as we saw before there. And in case you didn't spot it, let's just move this right to about here. There we go. They did, in fact, film what we call Earthrise and Earthset, basically the whole thing with the Earth reappearing from behind the moon and disappearing behind the moon in real time. And so you could actually watch it happen. It was pretty cool. All these videos are available on NASA's website, so you can check them out. And that little blue speck, that's where we live. That's kind of amazing. Going into the distance behind the moon, which is, of course, totally lifeless and no atmosphere, no water, no anything like that. But this image from the Apollo era basically kick-started the environmental movement. You know, that image of the Earth from space. Whoa, that was interesting. So it was pretty cool to see the whole thing happen. And Artemis is still in orbit around the moon, and it will be coming back around about December 11th. So it's still up there. They're doing some more tests. They're going to fire the engines again. They're going to make sure that, you know, the crash test dummies that are in the seats there are going to send back all the data that they need and so on. And we'll get this these glorious close-up pictures of the moon here as well, which turned out pretty impressively. I mean, these are navigation cameras, so they're really not designed for pretty pictures. But when you're in close to the moon, you might as well take pictures with everything you can. And these are just incredibly detailed, a little bit overexposed. You'd think the folks at NASA would be able to figure out exposures, but that's okay. And I haven't figured out which one of these images is my favorite yet, but I just love the spacecraft juxtaposed with either the moon or the Earth in the background. These have all been rotating through my desktop backgrounds for quite a while. I think this is my current favorite. Seeing the Earth from space like that is just wonderful. If this spacecraft performs properly, good things will happen. The main test is still coming. The number one priority of the Artemis 1 mission is to test the heat shield of the new Orion spacecraft, because that's never been tested coming back from the moon. When you're in Earth orbit, you're going pretty fast, and when you re-enter the atmosphere, all of that speed basically gets turned into heat energy, and you have to survive that to come down to the Earth safely. When you're coming back from the moon, you're coming back much faster. And so you have to be able to survive even more temperature. And it's only been done 7 or 8 times in the history of space exploration. So that's the number one test coming up in those last 3 or 4 minutes of space. Oh, hey, Desiree, nice to see you. Haven't seen you for a long time. Great to see you. So Artemis is just a wonderful thing to be part of. And NASA has gotten better at sort of sharing the video and the images as quickly as possible. So that's really nice. Let's see. So if Artemis goes well and the heat shield test works and all of that, then Artemis 2 will go into preparation. And Artemis 2 will carry 4 humans, one of whom will be a Canadian, around the moon in 2024. So a little more than a year from now. Now, interestingly, there are 4 Canadian astronauts, so each one of them, I guess, has a 1 in 4 chance of going. But there's 2 sort of senior ones who have been here longer and 2 junior ones. So it's probably not going to be the junior ones. And of the 2 senior ones, one of them went up on the space station already, and the other one hasn't. So I'm kind of leaning towards Jeremy Hansen as being the Canadian choice. That's what you would do if it was sort of a military kind of rotation. You would sort of pick the person who was next in line. They may choose someone else, I'm not sure, but we'll have to see. But Jeremy Hansen was in Winnipeg today. I didn't get the chance to go down and chat with him myself, but I know some of you were down at the museum and able to chat with him. So he just came through Winnipeg, and he will be coming back through Winnipeg fairly soon. So if you didn't get a chance to see him this time, we'll try and make sure that the news gets out a little bit better. The Canadian Space Agency tends to organize these tours with a little bit of secrecy and not release the information to the public sort of until the last moment. That's just sort of the way that they do this. In case, training schedules change and they have to cancel or move his schedule or things like that. So it's a way of not disappointing people, I guess. But it was nice to see him in town. All right. Oh, some questions here. Hollis, is Artemis going to be able to take photos of Tranquility Base? It's interesting. No, because all of the Apollo missions were basically near the equator of the moon, because those are the easiest ones to get to. Artemis is basically gearing up for the Artemis 3 mission, which will be a landing near the South Pole, pretty much at the South Pole of the moon. So the orbit is different. And so it doesn't really fly over those particular areas. Now, there may be the chance for them to get some kinds of shots or things like that. But I'm sure at some point in the Artemis mission, we'll get pictures of that. But pictures of the Tranquility Base and places like that have been shot by robotic spacecraft already. And you can find those online at NASA. Craig's asking, where will the spacecraft land? In the ocean, yes. Just like the old Apollo missions, it comes in through the atmosphere, pops the parachutes, lands in the ocean, and a U.S. Navy ship will go and pick it up. And they've been training to pick that thing up out of the water for a number of years already with a dummy capsule. So as long as things go according to plan, and as long as there's not a hurricane or something that happens to be happening right around then, they'll plop down in the South Pacific, and the crash test dummies will have a lovely, humid Pacific weather to come back to. All right, let me see here. One of the things that I wanted to talk a little bit about were some of the events that are coming up in the sky. And so let's just, oh my gosh, it's been 3 weeks since I've done a show, and I forget what buttons do what. It's amazing how quickly that knowledge basically falls out of your head when you're not using it. Another question here. Ulrika is asking, for the heat shield, can't they use data from previous missions to the moon? They have, but the thing is, this is a much larger spacecraft. And one of the things that is kind of counterintuitive, not everything is scalable. You can't just sort of say, well, if this is happening, if you double the size, then it'll be double the effect. So there's some uncertainty. They do have pretty good physics, pretty good modeling of what they expect to happen. But until you actually try it out, they won't certify it for humans to go on. They want to see a successful test in real life and not just depend on sort of the theory of the design. So that's the reason behind the heat shield test. Okay, here we go. This is the one I wanted. Here's our stellarium view of the sky. And we're now in the period of the year where I can set the sky for real time. So we're actually playing the sky in real time. And so this is what the sky looks like right now. And so if you were to go outside and look towards the east, you would see Mars rising a little bit north of east, the brightest thing in the sky. A couple of other bright objects nearby, the star Capella in the constellation of Auriga over here. And over here we've got Taurus the Bull with Aldebaran, which is also a reddish object. But with Mars being so much brighter right now, its red is much easier to see. As we move along over towards the southeast and south, we've got another bright object, the bright planet Jupiter, still up there. Jupiter is past its prime theoretically, although it still is very bright and very spectacular. A pair of binoculars still reveals some of the moons of Jupiter, and in a telescope you can see the cloud bands and things like that. Way off already in the southeast as darkness is falling is Saturn. Quite a bit fainter. Doesn't really jump out like the other planets. It's quite a bit fainter, but it is still a viable target in the early evening. If you have a telescope, it's a great place to be able to see the rings of Saturn. I'm going to zoom out here a little bit and demonstrate one more time how bad astronomers are at naming things. Here in November, the end of November, with snow on the ground, in the west we see the summer triangle. These three bright stars, the summer triangle, still up there. Yes, it is easier to see in the summer. It's up higher. That's maybe at its best, but it's actually visible for such a long period of time, as any seasonal stars are, that it's really difficult to, figure out the name. The Milky Way goes right through that. And right now, with us being very close to new moon, if you can get away from any artificial light pollution like city lights or things like that, the natural light pollution from the moon won't interfere, and you'll be able to see the beautiful Milky Way. Over here in the west, sort of the summer Milky Way, it arches right up overhead, right through the zenith, the point straight overhead, right through the W shape of Cassiopeia, and all the way down the other side of the sky, going down pretty much over towards Mars. So we get this whole view of the Milky Way arching right overhead. Off in the north, the Big Dipper is down at its lowest point. For me, I can't see it at all because of my own house and then the neighbor's trees. But it's still up there. If you've got a clear horizon, you can still spot it. We'll spend more time looking at constellations next week when we do our first show in December. We're going to take a look at sort of all the winter constellations, just remind you where things are and get in for a few other upcoming events. But that's sort of where we are in the sky right now. A couple of questions here. Oh, hi, Len. Nice to see you. Let's see. I was seeing the Earth when it comes back and seeing the Earth getting bigger and bigger. Yes. Will the landing be on our special events segment live? That's a good question. We scheduled the launch as a live event. We will also cover splashdown as a live event. I was originally hoping to have a splashdown party, but we're still not quite ready for big crowd events at this point, but we will be doing a live broadcast for the splashdown. I don't have a time on that yet, but whatever time NASA announces, we basically start an hour before that. And Ben pointed out on Artemis, they're studying the cosmic radiation using 600 varieties of yeast. There's so many scientific experiments. Like it's not common to have a spacecraft go out to the vicinity of the moon and be outside the Earth's radiation belts and any interference from the Earth. So this is a big, even though it's a test flight for NASA, it's really a big deal for scientists because there's a ride out to the moon and you can do your experiments without the interference from Earth. There are experiments, a bunch of little satellites that were basically put in as ballast and then deployed from the booster when it was sort of done. And some of the ones going off to an asteroid and other ones are testing different technologies. There's the yeast one and things like that. Lots of science going on, even though this is, just a test flight. Okay, yeah, I really like the flying laboratory. Exactly, Ulrika. It's like the space station, except the space station is so close to the Earth, you really aren't getting all of the benefits of being in space. You're getting the zero gravity or microgravity kind of environment, but in terms of the radiation environment, in terms of the just the closeness to Earth, it's so close to the Earth that it's not the same as being out in deeper space. So Orion, when it heads out to the moon, you definitely get a better view of that. Let's see here. Okay, let us move on to our featured topic for this evening, which is the planet Mars. We are now coming up to Mars's best for the year. It's been getting brighter and brighter over the last several months. If you have a telescope, it's now sort of close enough that you can start to see details on the surface of Mars. But seeing details on the surface of Mars is a challenge. Not only do you need the Earth's atmosphere to cooperate and to be free of clouds and steady and so on, you also need Mars's atmosphere to be free of clouds and steady and so on, because Mars has its own atmosphere. And so the light that we're seeing travels through two different sets of atmosphere. That makes it a fairly challenging target at the best of times. And it turns out that because Mars is one of the closer planets to us at its closest, it's not always at its closest. Sometimes it's on the far side of the sun, and we wind up having a huge variation in the distance from Mars. Sometimes it's pretty close, sometimes it's really far away. And so that means in a telescope, sometimes it gets to be a good size, but other times it's just this tiny little speck. And that is, I think, one of the things that can often disappoint people when they look at Mars with a telescope. You sort of think, oh, Mars, it's, Martians and canals, and we've imagined Mars for hundreds of years. It's the red planet. And then you look at it in your telescope, and it looks like this tiny red, tiny, slightly orange dot with no details on it. That's because it's only good at certain times. We're in one of those certain times right now. And so let's spend a little bit of time taking a look at the planet Mars. It's a pretty interesting planet. It is arguably the most Earth-like planet after the Earth. You couldn't go and live there, but it's got many of the same features that Earth does, just not to the same level. It does have an atmosphere. Mars's atmosphere is mostly carbon dioxide, though, and it's very, very thin. The air pressure is about the same as up on top of Mount Everest. The air gets thinner as you go up high. Well, that's what Mars's air is like at ground level. And there's no oxygen in it, so you couldn't breathe it. It doesn't have an ozone layer, so there's a huge amount of radiation hitting the surface and therefore hitting anybody on the surface. It does have clouds, but they're relatively small. It does have a polar ice cap. Here we've got, Earth's polar ice caps are pretty significant, or have been, up until relatively recently, I guess. Mars's change with their seasons as well. And as Mars goes around the Earth, it has 4 distinct seasons like the Earth does. It's tilted on its axis enough that there's enough of a difference between spring and summer and fall and winter that those ice caps will grow and shrink with the Martian seasons. It's got extinct volcanoes and caverns and a few impact craters and things like that. But probably the most common feature on Mars are made by water. There are dried up riverbeds, dried up lakes, dried up ocean floors. It's like most of the planet was covered with water, and water did all of its erosion and laying down of sedimentary rock and carving out valleys and rivers and things like that. And then all the water disappeared. Early in Mars's history, something happened. Mars is, a lighter planet than the Earth. It's smaller. It doesn't have as much gravity. And so perhaps some of its atmosphere started to leak away into space. And once the air pressure gets down below a certain level, the boiling point of the water actually goes down and it can boil away. And so you wind up basically dehydrating your planet because your atmosphere is not thick enough. We think that happened early in Mars's history. Despite that, it was one of the places that we thought there might be life. Water is an important element for life, and so when we go to Mars, we look for the water and we hope that we'll find life. Nowadays, we're actually thinking about life very differently, but that was the driving force behind the early explorations of Mars. The first spacecraft to get there were basically looking, excuse me, we're basically looking for life and for signs of water. And now we have, there's more spacecraft studying Mars right now than there was all throughout history. And we've got robots on the surface driving around little cars and a little helicopter. And being built right now is a mission to land there and pick up the samples that the Perseverance rover has been collecting and bring them back to Earth. So we'll actually have some Mars substance here in the laboratory that we can sort of experiment with. And here's how they get those. This is basically a little drill hole. There's a drill on one of the robot arms on the Perseverance rover. They drill down, grab a rock core, just like geologists do here on the surface of the Earth, looking for minerals, except here we're looking for, well, minerals, but minerals that formed in the presence of water. This is one of my favorite Mars pictures of recent years. This is the Perseverance rover on the right. It has taken a selfie with its robot arm, and in the background there on the left is the Ingenuity helicopter, or Ginny as we have nicknamed her. Ginny has flown, it was only supposed to work twice basically as a test. It's flown about 25 times now and taken some great footage and just has really proved itself. So this is sort of one of the current explorers, and we almost get used to seeing these pictures and it just looks like a place. It doesn't look like this magical, mythical planet Mars. It looks like a desert place that is familiar to us now because we've seen it through the eyes of these rovers. This is the Chinese rover that landed back at the same time as Perseverance, basically, or near the same time. And it's also been exploring and taking all sorts of great images and things like that. It doesn't get sort of the same level of publicity. But many countries have set their sights on Mars. And in fact, the Artemis mission, getting people back to the moon and doing so in a sustainable way, is really as a stepping stone for eventual human exploration of Mars. Humanity will eventually leave the Earth and not come back. There will be people that are born in space and live their whole lives on other worlds. We're not there yet, but we will be because humans expand. It's kind of what we do. Right now, it's the robots on Mars, though, and they're doing a great job of all the geology. But one day, there will be Mars colonies. And there are already Mars colonies here on the Earth where they're testing all sorts of different techniques. And, if you saw The Martian, you have to be able to grow your own food because you can't possibly bring enough food to survive a long mission on Mars. All of these things are being tested now on the Earth. And so that's kind of one of the side benefits of having a space program like this, is that if you're learning all about agriculture so that you can plant things on Mars, that's also going to apply to agriculture here on the Earth. And a number of advances in agriculture and food processing and things like that have actually come from the parallel research happening in the space program. Okay, here is, actually, before we get into this, let's take a look at, there's some questions here. We've got, let's see. Lizeth, I will talk about telescopes right at the end so that I'll give you a couple of recommendations for that, okay? Phil is asking, if Mars has no way of protecting from radiation, how do all these scientists propose to settle on it theoretically safe? Well, that's a big problem, to be honest. Probably the best way to do it is, and you sort of see it in this artist's rendition here, you cover everything with Martian soil. The Martian soil, if you put enough of it there, it will block out the radiation. And so that plus your spacecraft design, which will also have radiation shielding sort of built into it, is supposed to be enough. That, I'm not sure exactly what the safety margins are there. I do believe that they do expect, slightly higher rates of radiation-related illnesses and things like that. But they're sort of at the point where the first people to go will collect the data that we need to sort of make it better and better each time as each crew goes on, I guess. And Ben said that I heard Mars's greenhouse gas was hydrogen. Yeah, it's interesting. Mars doesn't really have a thick enough atmosphere to have much of a greenhouse effect anymore. But back in the day, when there was water, there was probably some hydrogen from the water that was there, and that would be a greenhouse gas for sure to some degree. But now the atmosphere is largely carbon dioxide, what there is, and that is definitely a greenhouse gas. So Mars is actually warmer than it would be if it didn't have an atmosphere. But it's such a thin atmosphere that it really doesn't have a major effect. Let's see. That was the same question, I guess, Phil. Okay. Would you age faster on Mars? Asks Yasmina. I don't know. I've seen some of the rocket designs and things like that, and I feel like I would age just riding the thing there. There's no real change to your biology, so you would still, your hair would grow at the same rate, and your fingernails, and your body would sort of age at the same rate. You might track it differently because Mars goes around the sun every 26 months. So if you were measuring your birthdays in Mars years, you would celebrate, your first birthday after 26 months, rather than after 12 months here on the Earth. Calendars get kind of wonky. I imagine, though, that initially they would just keep the Earth calendar, and people would just, use their computer to tell them when their birthday is, just like we do now. I mean, if it wasn't for social media reminding me when everybody's birthday was, I would never remember these things. So I imagine it would be the same kind of thing. Ulrich is pointing out this is kind of like Moonbase Alpha in Space 1999. There's a lot of sci-fi design that happened in the, for books and TV shows and movies in the 60s and 70s and 80s that seems strangely prophetic. Because it's based on real science. And now when you see the current designs being created, they are kind of very similar. Yeah, absolutely. And Ben points out the length of the day is just a little longer on Mars. It's 24 hours and 38 minutes, something like that. So your clock, your watch would have to be set slightly differently to match the idea of, the sun rising in the morning and setting in the evening and stuff like that. Otherwise, it would get out of sync. When the rover controllers go on shift, they set their clocks by Mars time. You can actually buy from NASA a watch that runs at Mars time. And they operate on Martian days because they basically need to be able to function during daytime on Mars. It doesn't matter what time it is here on the Earth. So that back and forth calendar and clock thing is always going to trip us up a little bit, I think. Look how well we handle daylight savings time, right? Okay, so this is a great diagram from the the Association of Lunar and Planetary Observers, ALPO, which is basically a group of amateur astronomers that take pictures of the planets for scientific purposes. So basically they're trying to get high resolution images on a regular basis, because while there's a rover there, that's great, but the rover can only see what it's standing on. You want to see the whole picture of Mars. Well, even the satellites that are in orbit around Mars don't see the whole planet every day. It takes several days to build up a map of the whole planet. So these amateurs sort of get this global view, and they are the ones that often point out the alerts of things like a big dust storm breaking out, or large cloud formations, or things like that. This tells you a little bit about, here's Mars at the beginning of December when it's near its closest, and it's a fairly big kind of view. But when you look at what it was in May, it's just this tiny little disk, and that's actually better than it normally is. Earlier in the year, it was about half that size. So Mars really does vary in its distance from us. That means it varies in its size, and it means that we get to see different parts of the planet, or a different view of the planet as it gets closer. The other thing you might notice here, up here, here's the North Polar Cap and the North Polar Cap. But actually, as the year goes on, the north side of Mars sort of tilts away from us, and we start to see the south part of Mars, and we see the South Polar Cap. Or, sorry, I just realized this diagram is flipped. So everything the opposite, I said. And then basically, after the first week of December, we wind up, shrinking away by the third week of January. It's still pretty good. So basically, any time from, October through January, end of January, beginning of February, you have a pretty good-sized view of Mars. And so that's really prime time. We've been checking it out quite a bit. It's in the first half of this window, it rises after sunrise. Right at opposition, it rises right at sunset, and so it's up all night, but it doesn't get high enough to get a clear view until 9, 10 o'clock. This part of the window, from December to the third week of January, it's rising earlier and earlier in the evening. It's getting higher and higher earlier in the evening, so it becomes more convenient for most people to view it. So that's probably when you'll see a lot of the really good imaging coming out from amateur astronomers, because just more people have time to get out there and see it in a nice, high, clear sky. Let's see now. I think we have a little bit more imaging of Mars to show. I just have to, okay, I guess we don't. So the planet Mars, like I say, it's close to being at its best. Coming up, it will be even brighter than it is now. It outshines pretty much everything in the sky except maybe Jupiter. And it's very close to Jupiter's brightness coming up. We'll be able to watch it for the next several months. And if you have a telescope, it's a great time to look for it. If you don't have a telescope, we have a couple of options. We're going to be doing some live streaming, of course. And then coming up at the Manitoba Museum, there are a number of events that I'd like to tell you a little bit about. And one of them is First Fridays. The first Friday of every month, there's a free event going on at the Manitoba Museum, Planetarium, and Science Gallery. They're open from 4 to 9 for free, running all sorts of things. But if it's clear, we'll also have telescopes set up starting at 6:30. And hopefully, we'll be able to see Mars towards the end of that window. Around 9 o'clock, it should be up high enough that we can see it past the buildings. Because unfortunately, downtown, there's all these buildings in the way of the stars, which is really annoying, but we'll do what we can. So that's something to watch for. And again, that's free. And there'll be planetarium shows and other things going on throughout that whole time. This is a cool thing. On the night of Mars's opposition, when it is exactly opposite the sun, something else is opposite the sun, the moon. And in fact, the two things line up. Mars will actually be covered up by the moon. Like an eclipse, technically we call it an occultation, but it's like the moon eclipsing Mars, passing in front of it. Mars will disappear behind the full moon and then reappear. We're going to do a live broadcast for that because it'll be really cool to watch. Fairly rare event. The moon doesn't often occult bright planets. And so that'll be fun to watch. We're going to start broadcasting at 8:30. The planet Mars will disappear behind the moon at 9:05 p.m. Central Time here in Winnipeg. It'll be a few minutes before or after that, depending on where you happen to live if you're across the country. And then it will reappear a little bit more than an hour later at 10:16. Again, here from Manitoba. So that'll be fun to watch, and we will absolutely bring that to you live, assuming we have clear skies anywhere within 100 kilometers or so, whatever my driving distance is that night between the end of work and dinner and the beginning of the eclipse. That's basically the time that I have to drive. And then we'll have a couple more events. The Geminid meteor shower comes up in December. We've been live streaming this every year for 3 years now, I think. And we've got an all-sky meteor camera that we just set out there and watch the meteors. The Geminids is the best meteor shower of the year. It is much better than the Perseid meteor shower in August. It's just that the Perseid meteor shower is in August, and people don't mind lying out under the stars in August. It's a harder sell in December. But you can watch it live. And the great thing about the Geminids, they're actually active before midnight. Unlike most other meteor showers, they're active before midnight. So we're going to start streaming at 8 o'clock on the 13th, and we'll go as long as we can. The moon does come up a little bit later, and that spoils the show a little bit. So we're going to try and catch some of those earlier dark skies, see how many Geminids we can see that night. And then, we have the Dome at Home holiday show, Thursday the 15th. That's it's kind of like a call-in show in some ways. I'd like to invite folks to come on the show and just chat. We'll get you to turn your camera on, and we'll talk a little bit about astronomy and ask questions or whatever you'd like to do. And we'll go over the events for the coming year. We'll talk about what there is in the realm of eclipses and planetary alignments and meteor showers and comets and all that kind of stuff as well. So that's a fun thing. So that's on the 15th. We do have a show next Thursday, which is at the beginning of December, that for some reason we didn't have a slide for, but that will be on Thursday, December the 1st. Is that right? Thursday, December 1st, yes. All right. Boy, 3 weeks away from the broadcast studio, and it's pretty rough. I apologize for being a little bit off my game here, but it's been one of those times. Let me just check our questions here. Oh, Fallon's asking, how long is the time between oppositions? Back when we were talking about Mars, about 26 months. So, and it turns out that each opposition isn't exactly the same either. We have some oppositions that are even better than average, and then some oppositions that are quite poor. And Mars can appear quite high in the sky for us here in Canada, or it can appear quite low in the sky for us here in Canada. So there's all these sort of long-term cycles. The bottom line, though, is to sort of catch it when you can and take as many views as you can of Mars when it's clear and close. That brings us to the end of our show for tonight. Thank you all for joining us, and again, apologies for the delay. We'll be back on our regular schedule next week. It is really gratifying to see that we have almost the same number of viewers tonight that we would on a regular night. So obviously, either a bunch of new people joined us to make up the difference, or you all found us and were able to find things. So I appreciate the Dome at Home family for being such a great community. We had a question about telescopes, and I did want to talk a little bit about telescopes. I actually just had a telescope course on Tuesday where I did a couple of hours about this. There are a couple of telescopes that I have found that are really, really good. And probably my favorite one for a beginner is the Celestron First Scope. It's about $100 from the mail order places that I've seen it. I haven't found anybody that has them locally, but it's about $100, and it's a great little telescope. It's nice and portable. It's easy to use. It doesn't have a bunch of bells and whistles and things like that. And then there's a slightly larger version, I guess, from Orion, which is called the Orion Sky Scanner. I ordered one of those from Orion in California, and it cost $367, including shipping and U.S. exchange and stuff like that. It's a 4-inch telescope, so it's a good size. It's not a toy telescope, and is still nice and portable, nice and easy to use. Comes with everything you need to get started. And those are kinds of the things that I would suggest for a beginner starting out. The other thing that I often suggest is join the local astronomy club. The Royal Astronomical Society of Canada has a library of telescopes that its members can take out. And membership costs I don't remember the exact number, but I think it was about $82 for the year last time I looked, or last time I paid. Might have gone up a few dollars, I don't know. But for that, you basically can use all of the telescopes in their library. They have everything from small telescopes. They have a couple of 8-inch Dobsonians. They have a specialized telescope for looking at the sun. They have telescopes designed for taking pictures. And they even have a big observatory telescope in a dome with computer controls and the whole shebang. So, you know, a big expensive observatory for $82 a year is a pretty good deal. That's also the only way that you can really sort of test drive telescopes, I would say, because there's not a lot of places that have them available otherwise. All right. Thank you all. Great to chat with you. Oh, hi, Terry. It was nice to see you. I was wondering if that was the same Terry that was from the show. So it was great to see you at the course. And yeah, enjoy your evening. Get out there under the sky. It looks like it's clear. Enjoy the planet Mars and all the other things that you can see right now. And we will see you next week on the 1st with another edition of Dome at Home. Thanks, everyone. Good night.